I know what you're all thinking. Cold opening, he's sitting in a deck chair and he's got a cup of tea in his hand, and this can't be good, but do not worry. I thought I'd take a second out to explain a bit behind this episode. First of all, I apologise, the continuity of this episode is terrible, it's a bit all over the place, but the reasons why will become apparent in a second. Every time I record something for one of these episodes, I file away the footage in a folder which is labelled with a time, date and location. This makes editing it all together afterwards much easier. While going through these folders, I found that the first bit of footage taken for this episode was recorded back in February 2021. At the point of recording this now, it is currently November 2021. Anybody who's in the UK or was following UK news back in February 2021 will remember what it was like back here. And while I don't want to keep using it as an excuse, it does go some way to explaining why this episode has taken so long to produce. Unfortunately, it stopped me getting access to equipment I needed and help from someone in order to complete it. You may have noticed that every episode tends to be focused on an individual part of the build, and I've done this for a couple of reasons. The first one is it forces me to get parts done, and if I come across a problem, I have to face it, sort it out, rather than leaving it later on in the build. Often as happens with project cards, it never gets done. The other reason is in case anybody wants to do this conversion or a similar one, they can kind of use these episodes somewhat as a guide to what needs to be done, and they don't have to go trawling through multiple episodes to find the information that they want. That being said, I hope you enjoy this episode, and in the meantime, I'm going to crack on with some necessary upgrades that are required with the garage. Driveshaft. Welcome to another episode. Today it's currently raining outside, it's pretty horrible, wet, miserable, so I've decided to retreat to the safety of my garage. In the near future I actually need to do some work on this garage, and to do it I ideally could do with moving the Mini out of the way. In order to do that I need to fit the suspension and the wheels. To fit the wheels on the Mini you need to have, as a bare minimum, the outer CV joints. If I'm going to do that, I might as well go the whole hog and build the drive shafts, as it's a job I've got to do anyway. So today we're going to look at the drive shafts. What you can see here on the bench are the original shafts from the micro donor car and a couple of mini drive shafts. There are a few ways of doing drive shafts when it comes to engine swap cars. The first way, and the way that everybody will tell you to do it, is to take some measurements and send them out to a company that specialises in making drive shafts. Contrary to what you see in a lot of YouTube shows, drive shaft places and my experiences in the UK are not that common. There are some out there, but around me I've yet to find one locally. The other thing is the few that I've inquired with are expensive. The next option is that you send out your original shafts either from your donor vehicle or the original ones for your car, and you get them machined and modified so that they have the correct splines on both ends. We ideally need to combine the mini outer CV with the micro inner CV. The final way of doing it, and the way that everybody will complain at you, tell you it won't be balanced and will never work despite countless vehicles having them, is to do the so-called cut and shut method. This requires you to cut both your original drive shafts and the drive shafts in the donor vehicle, weld them together and sleeve them. Guess which method we're doing? For the record, I hate drive shafts. I can't think of another job, to be honest, on cars that I dislike more. Most people are not a fan of wiring, but at least it doesn't create the mess that working with drive shafts does. Unfortunately, it's a job I've got to do, so let's bite the bullet and get on with it. As I said, first job to do, strip these ones apart. Sometimes your CV joint won't want to come off a shaft because of the clip inside, and the reason is because it can be pressed up and isn't allowed to spring back into its slot. So a trick you can do is to drive the CV back onto the shaft, which doesn't allow it to fold in, and you need to get it with like a sharp tap, and the TV will go past pushing the clip in, like it's going to shaft. You can see it just popped in and now it's coming off. Don't worry about how I'm treating the CV joint, it was already damaged and isn't needed as it's the Mini's inner one. There, you can just see it as the clip in question. And the micro shafts are in considerably better condition. The outer CV we don't need, so I can be a little bit rougher with that, but the inner one is obviously the one that is important to us because that's the one that goes into the gearbox. They also come along with these balance weights that are fitted in the middle. Obviously we're building custom shafts, so these are not going to be correct, so these also have to come off. They're required to allow us to cut and weld them anyway. CV bits. It's been about a month since I stripped the micro and mini drive shafts apart. The next step I need to do is to measure up for those shafts. In order to do that, I have to put the suspension back in. And putting the suspension back in, I might as well also start looking at where I need to mount the brake pipe to the brake caliper. It should be noted at this point I never actually got round to making these mounts. However, the subframe lower brace bars to which they will be joined to were made. In order to do that, I'm then going to have to make the brace bars that go from the tower down to the front of the subframe, which is a job I've been putting off for a while for no particular reason, but it's got to be done, so now's a good time as any to do it. I started making the cardboard template by cutting some 25mm wide strips. The idea was to make one template which I could fold inside out to make the mirror image for the other side. So I created a template and then created a more accurate template. So now we need to turn this into steel. Now that I have the brace bars tacked in place, I have one last job to do before the suspension can be fitted, which is to make some new lower arm pins, as the standard mini ones can't be used. Before I rush off and start machining two brand new pins, I've managed to salvage these two cut ones from a spare set of bottom arms I've got. Now I didn't cut these, however these are probably going to end up scrapped, so I might as well try attempt to use one first. What I do require though is to move this flange slightly further down the shaft that way. As well as moving the small flange, I also had to get rid of the remains of the old bushes that was left rusted and attached to the pins. Now that I've managed to get rid of what's left of the old bushes off these pins, I now need to cut the welds from this flange to the pin out and move this. Now, my chances of getting this piece off intact, I think, are probably pretty much slim to none, so I might as well just destroy it and make myself a new one. The final step of machining on the lathe was to use the parting off tool to mark the length of the part. I didn't fully part it off so that I'd have a large enough workpiece that could be held in the vise of the milling machine.
Right, we've now finally got to the point where we're measuring for a drive shaft, and in order to do that we need to get the CV joints in place. Now the inside one is fairly easy, that just slots into the gearbox, which is obviously fit to the car. The outer one is in the hub. To mount the hub we also need to put the suspension back in. I'm not going to put all of the suspension back. There's what's called the rubber cone, which goes up inside there. That's the spring in the Mini's front suspension, and there's another part called the trumpet that connects it to the upper arm. In order to measure for drive shafts, we need to be able to cycle the suspension, and all those components are going to do is put pressure and push the suspension down, making it difficult. So we're going to omit them for the time being. This is the upper bump stop, its spacer. The lower bump stop.
The next part of the suspension to be fitted was the lower arm. While I did use a metal spacer when welding the mounts in place, it was a little tight and difficult to line the pin up, so this is something I might adjust if I build another subframe. You might also notice that I didn't fully seat the pin, however as it all has to come back apart again, it didn't really matter at this point. After fitting the lower arm, it should come as no surprise that the upper arm came next. And finally the hub, to which I'd already fitted the outer CV joint and the drive flange. When measuring for the drive shaft, you need the suspension in its position, which will give you the shortest length. That is usually straight dead ahead and with the outer CV at the same level as the inner. I say usually, there is probably a suspension geometry somewhere where it's in some other position. When you turn the wheels or it cycles, your drive shaft length generally lengthen, so you need it to work out what the shortest is so that you don't bottom out and bind the inner CV. So we're going to get trolley jack underneath this and get it in the right position, and then start taking some measurements. Before I go cutting up the best part of 50 quid worth of mini and micro drive shafts, it would be a good idea to make a template. So that's exactly what we're going to do at this piece of broom handle. The measurement I took between the Mini's outer CV and the Micro's inner CV is 570mm. Now, that might sound a nice round figure. That's because it is. It's about as close as I could accurately measure it. If you're out by 2 or 3mm on this, don't worry about it. Your inner CV's usually got enough scope to compensate. I basically had to bend a tape measure in order to do it. This is from the outermost surface of the inner tripod joint to the innermost surface of the Mini CV. It doesn't take into consideration the shaft that goes inside of the CV joints. Now I need this for the template because the CV joints have got to sit on the piece of broom handle that's going to be turned into it. This is the micro shaft, so we need to know what that distance is there from the inside of this to the end of the shaft. This is the mini drive shaft, and it looks very similar. I know, if you've actually ever tried fitting mini CVs onto a micro shaft, you will find they fit. Again, I think more copying from the drawing office. Anyway, again, we need to know the measurement from this side of this built-in flange to the end of the shaft. You can always tell mini shafts because the other end is quite distinct, and this is useful if you stripped all your shafts apart like I have months ago and then have forgotten which one's which. At least I know this one's the mini one. So let's take these measurements and then move on from there. The Mini's drive shaft is 24mm. And amazingly enough, the Micro's drive shaft is also 24mm.
If we added up all these figures and made the template drive shafts to these measurements, what you'd find is that the drive shaft would bind. That's because the inner tripod joint was pushed all the way into the inner CV. That obviously joint will slightly move and rock back and forth inside the joint as the suspension cycles. However, it doesn't tend to move that much. So, rule of thumb from experience, I've learned around about 1/4 inch, 6mm, deducted from this should give us a good drive shaft. That's probably a good place to start. Worst case scenario, the dowel's too long and I just have to cut it down. It's much easier to modify a £1.49 broom handle than it is 50 quid's worth of steel drive shafts. So this gives us a total length of, see how good my maths is, 612mm.
That's it for this episode. Come back next time and find out if I really am going to cut through 50 quid's worth of drive shafts and weld them together. If you've enjoyed this episode, then please click that like button and share. And if you want to keep up to date with the build, then please subscribe to my channel. Thanks again for watching.